Okay, for this lesson, we're going to talk about two things. First, we're going to talk about a concept called distribution. And distribution is just a fancy way of saying that when we put two categories into a categorical statement together, or a categorical proposition together, we learn something about the entirety of one of those categories, and sometimes about both of the categories. But we need to learn something about the entirety of it. So that's what distribution means. So we say it's distributed when we learn something about every member of that category. And then the second thing we're going to work on is our three operations. These operations are called conversion, obversion, and contraposition. Conversion is a way of switching the subject and the predicate term of a statement. And then obversion is the way of changing the quality of a statement from like an affirmative to a negative or a negative to affirmative, but you got to make another modification as well. And then contraposition is a way of switching the subject and predicate of other statements, but you have to do something else to it. So we'll see how those work. Those operations only work on specific statements, so we need to learn one, how the operations work, and then two, what statements the operations work on. So that's going to be today. Let's go ahead and start with distribution. So distribution once again means that when I put a term, either the subject or predicate term, into the categorical proposition, some new information is given about every single member of that term. So it's important to note I know something new about every member of that category. So if we say all dogs are canines, you have here dogs. What do we know? If you have just the word dogs by itself, you know, okay, a dog is a dog. But when you put it into this sentence, all dogs are canines, you know something new about every single dog. What do you know new about it? You know that it's a canine. And so we would say here that dogs is distributed. And so that goes for all of the A-form statements. So A-form statements A-form statements distributes the subject. But it doesn't go in reverse. So when we have canines by themselves, okay, a canine's a canine. But do we know something about every single canine in this sentence? We don't know that all canines are dogs. That's not the way the statement goes. It only goes in one direction. And so we don't know anything new about every single canine when we put it into this statement. So we wouldn't say that this is distributed. So A distributes the subject, but not the predicate. All right, let's look at the next one. No cats are dogs. Well, when we put this term cats into the statement, we know something new about every single cat. What do we know? Well, we know it's not a dog. So E distributes the subject. Do we know something new about every single dog? We do. What do we know about it? That it's not a cat. So E distributes the predicate as well. So E distributes both. Next one, some students are left-handed people. Do we know something about every single student here? No, because this says only some of them are left-handed people, so we don't know something about every single student. So this is I doesn't distribute the predicate or the subject. Let's look at the left-handed people. Do we know something about every single left-handed person here? Some students are left-handed people. Do we know something about every single one? No, this doesn't tell us about every single left-handed person either. So I distributes neither. Does not distribute. Okay, so what we have here is the A form distributes the subject but not the predicate. We know something about every member of the subject term but not every member of the predicate term. E, when we put the terms in the categorical statement for the E form, it does distribute the subject and it does distribute the predicate. The I form, when we put it in the subject and predicate into the I form statement, it doesn't distribute anything. Once again, the A, E, I is just the A is for all SRP, E is for no SRP, I is some SRP, and the last one, O, is some S or not P. Now this O form statement is a really confusing one, so I'm going to take a second and do that one all by itself. Here's the statement. Some people watching this video are not people who like Star Wars. Okay, so people watching this video, let's say there's two groups. There's the people who like Star Wars. We'll say that's 1,000,000. I know 1,000,000 people aren't watching this video. And then of the people who do not like Star Wars, there's going to be 1,000,000 like it. And this is going to be who doesn't like Star Wars. We'll say 2 people don't like. Okay, so some people watching this video are not people who like Star Wars. So think about this whole statement. Is this whole statement referring to some people watching this video are not people who like Star Wars? Is this talking about these 2 on the right side, or is it talking about the 1,000,000 on the left side? Take a second and think about that. So that's going to be the 2 on the right side that we're talking about. So some people watching this video are not people who like Star Wars. Okay, so what do we know about every single person in the world who likes Star Wars? What do we know about every single person in the world who likes Star Wars? We know that they are not one of these 2 people. What do we know about every single person in the world who does like Star Wars? They are not one of these 2 people. These 2 people are the people that this sum is referring to. So they're the people that this subject term is referring to. So of all the people in the predicate class, we know they are not those 2 people in the subject class. And so the O form statement distributes the predicate. This is an obscenely difficult concept to get for a lot of people. It was really tricky for me to get. It took me a long time, even as a teacher, to make sense of this concept. I think giving it a very specific example where you count the people who are on the some are and some are not side, and then contrast that with the predicate term is the only way I can think to make sense of this. But if you don't get it, don't worry, there's kind of a last resort that I'll move into next. But for now, hopefully some of you have conceptualized this and you get why the predicate term is distributed here. But if you don't get why the predicate term is distributed here, don't worry, you're not alone. There's a ton of people who have a difficult time with that concept. But let me just repeat it one more time. This is the best example I can give. So some people watching this video, we have the people we're referring to then are the 2 who don't like Star Wars. So some people watching this video are not people who like Star Wars. And so what do we know about every single person who does like Star Wars, which is our predicate term? What do we know about every single person who does like Star Wars? They are not one of these 2 people. So the predicate term is distributed in this. Now the question is, do we know something about every member of the subject class? Some people watching this video, do we know something about every single person in the subject class? No, we only know about some of them. These in particular, we're talking about these 2 here, but we don't know about all of them. So this doesn't tell us something about the subject class. So distributes the predicate, not the subject. Okay, so that is distribution for the A, E, I, and O forms. Now let's go ahead and look at, for students who have a difficult time with conceptualizing those, here is kind of the end of the day what you need to be able to do. I have up top here on this slide distribution a dash. I'm going to complete that bar out. A dash means that it is not distributed, and a circle means that it is distributed. So we have the A form, the E form, the I form, and the O form, and then I have the subject term and the predicate term. So the A form, as we already walked through just a second ago, does distribute the subject term, so I'm going to put a circle there. It does not distribute the predicate term, so I'm going to put a dash there. The E form does distribute this subject term, so I'm going to put a circle there. It does distribute the predicate term, so I'm going to put a circle there as well. The I form does not distribute the subject term, so I'm going to put a dash there. And the O form does not distribute the predicate form, so I'm going to put a dash there. And then finally, the O form does not distribute the subject term, but it does distribute the predicate form. So you've got A distributes the subject, E distributes both, I distributes neither, and O distributes the predicate. However you remember it, what you need to remember is what is distributed in each case. So if I gave you a sentence, some dogs are green, you would need to know that's an I form statement, and neither dogs nor green is distributed there. If I gave you a statement that said no cars are trucks, you would need to know that that's an E form statement, so both subject and predicate term are distributed. So this is one of those ones where I'll say it's as a last resort, you just need to know how it works. You don't need to grasp the conceptual understanding of it, but hopefully you do grasp the conceptual understanding, because that's kind of the more important thing. But as far as surviving the class, you just need to know how it works. Okay, next we need to move on to the operation. So let's move to the next slide. So how does conversion work? That's the first of three operations. We're going to do conversion, conversion, and then we're going to do obversion, and then we're going to do contraposition. So those are the three operations we're going to work through. Starting with conversion, that one's pretty straightforward. You just switch the subject and predicate term. And so we'll practice on no S or P. That would just go switch subject and predicate, and your final statement would be no P or S. And that's all you got. The letters it works on, the way to figure out what letters it works on is we're going to refer back to our Venn diagram, and we're going to draw the pictures, and if the pictures from the Venn diagrams match, then we know that it works on the term, because the pictures is just a visual representation of the logical content. So let's go to conversion and do some Venn diagrams. So starting with all S R P, if you convert that statement, you would read it as you switch, step one, switch the subject and predicate, and so you would say all P R S. Now, all S or P, I'm going to draw a Venn diagram, put an S on the left circle, a P on the right circle, and then all PRS, we're going to do the same Venn diagram. We're going to put the S in the same place and the P in the same place. So let's see if these pictures match up when we finish plotting them out. So all S or P, remember the dashes means nothing exists here. And if we want to say every single S is a P, then we need to get rid of this space that allows for S's that are not P's, because we want to say that all S's are P's. So there's the Venn diagram to show all S or P. Now, how do we Venn diagram all P or S? Well, we want to get rid of the space that has a P that's not part of the S, because we want to say all P's are S's. So now, if you're a P, you have to be in part of the S circle. These pictures are not the same, and so the logical content of these statements has changed when you did the converted form. And so conversion does not work on the A form. Let's try the E form. So let's put a little tab here. We'll go A, E, I, O. A form it did not work on. Let's try the E form. So you have no S, R, P, and we're going to convert that to, what do you do for conversion? You switch the subject and predicate. So it's going to read as no P, R, S. Okay. The first statement is going to draw out with a Venn diagram. You have your S and you have your P. No P or S. I'm sorry, no S or P is the first one. So no S or P's, you got to get rid of the space in the middle that shows an S that is also a P. Then no PRS, That one, S on the left, P on the right, no PRS. Well, if it's a P that's not an, you can't have a P that's also an S, then you got to get rid of that middle space again. And so these two Venn diagrams visually do match up, so the logical content is the same. As far as logic is concerned, it can't tell the difference between these two statements. So conversion does work on the E form. Let's try the I form. I form is going to be sum S R P. Take a second, think through how that conversion is going to work. That's going to read as sum PRS So the first Venn diagram that represents the original statement, sum SRP, so you have S on the left, P on the right. There's going to be an X in the middle to show that there are S's that are also P's. Now the second Venn diagram that represents the second statement, sum PRS, S on the left, P on the right, you want a P that's also part of the S circle. Well, that's going to be in the middle as well. And so conversion does work on the I form as well. Let's check the O form. So you have sum S R naught P, step 1, sum P R naught S. Just switch the subject and predicate. We'll do the top Venn diagram. You have S and you have P, and then you have the bottom Venn diagram, S and P again. Okay, so you want sum S R naught P. That's going to be an S that needs to be in the S circle but not part of the P circle. So we'll put that there. That's the top statement. And now if you go to the bottom statement, sum P R naught S, that's going to be part of the P circle but not the S circle. These pictures don't match up either. So the O form statement does not logically is not in a logically equivalent statement. So conversion then works on the E and the I form statements, and that's it. So we can have a final thing to say about conversion then. We can say conversion, 1, you switch the subject and predicate. In step 2, it works on the E form in the I form statement. So there's conversion. Okay. Now, before we move into the next one, which is going to be obversion, we need to talk about this idea of term complements. So a term complement, what does that mean? It just means add or remove the letters non. So you're going to do a hyphen non. For example, a tree, the term complement of a tree is a non-tree. The term complement of non-pineapples are pineapples. The term complement of three-toed sloths are non-three-toed sloths, and the term complement of houses are non-houses. And finally, the term complement of non-garbanzo beans would be garbanzo beans. So you're just adding or removing the word non. Okay, why do we need to know what that means? Because for obversion, step 1 you change the quality, and step 2 you term complement the predicate. So let's try that one. How does obversion work? So step 1, change the quality of the term. Now, if we're practicing on the statement no SRP, that's an E form statement. In this case, we're starting with E, so we're going to go to A. So you go from no SRP to all SRP. And then step 2, you term complement the predicate. So you're just going to put a non in front of that P. All S are non-P, and that's obversion. So 2 steps, change the quality, and then you term complement the predicate. All right, let's go ahead and work through some examples of this one to figure out what letters it works on. Okay, step one. So we'll go all S, R, P. Step one, you're going to change the quality to no S, R, P. Step two, you're going to term complement the predicate. So you're going to say no S, R, non, P. Okay, to make more sense of this, I'm going to draw a big Venn diagram and we need to look at some various parts here. So if you have your S and you have your P, in your S circle there's two parts. There's this S on the left and then there's that overlapping S that's in between the two circles. On your left side, that part of the S is a non-P. In the middle, that S is also a P. And then on the right side, you have a P and it's also a non-S. So those are the various parts. And actually you could also say outside you have a non-S and you have a non-P. So if S stood for sharks and P stood for purple animals, and let's say one shark swam through some purple ink, so there was a purple shark floating around in the ocean. The left side would be a shark that's not a purple animal, so that would be like a great white shark. The middle would be that shark that swam through the purple dye, so now you have your shark that is a purple animal. And then the right side would be all of your purple animals that are not sharks, so poodles, all the poodles running around that are dyed purple, those are purple animals that are not sharks. And then outside of it, you have your non-S and non-P. So those are not sharks and they're not purple animals. So my car, that's not a shark and it's not a purple animal. The computer is not a shark, it's not a purple animal. So really this is everything else that you could think of. My coffee cup is not a shark, it's not a purple animal. So those are the four categories we need to work on. Right now we just need to focus on the three inside the Venn diagrams. So all S or P, let's draw our arrow over and look at the first Venn diagram. So we want to say all S or P. You want to do the shading on the left to say if you're an S, now you have to be a P. The only place S can exist is in the P section. Step one is an intermediate step. That's not an answer for the final problem. It's just a step getting there. The final answer is step two. So step two, we have no S or non-P. That's the final answer. And so that Venn diagram is the one we're going to be looking at. P, S. Okay, so we're going to say no S's are non-P's. Let me really quick draw the Venn diagram down at the bottom of the page, but I'm going to add some numbers there so you can know exactly what areas I'm talking about. So we have S, P, we have space 1 in the left, space 2 in the middle, space 3 on the right, and space 4 is outside. So space 1 is where you have sharks and non-purple animals. Space 2 is sharks and purple animals. Space 3 are purple animals and non-sharks, and space 4 is non-sharks and non-purple animals. Okay, so all S or P we're shading in space 1. Now no S are non-P's. First question, where are the S's? The S's are in space 1 and 2. And we want to say between space 1 and 2, none of them, either 1 or 2, none of them are non-P's. If none of them are non-P's, well, space 1 is a non-P, and we want to say none of them are non-P's, so we have to make space 1 go away. And now between spaces 1 and 2, the only thing you have left is space 2. So if I want to say no S's are non-P's, space 1 and 2 are both S's, but we want to say of those two spaces, none of them is a non-P, so none of them is a space 1. So space 1 has to go away. And visually, the original statement, all S are P, matches the final statement, no S are non-P. And so, yeah, these are identical statements. So obversion works on A. Let's see how it does with the E form statement. And right now I'm going to erase the sharks and purple animals and just go back to S and P, because now we're going to do something that has no overlap to it and I don't want to confuse. So we're going to say no S R P. Okay, so no S R P is our original statement. We're going to, step one for obversion is to change the quality. So we're going to go from an E form statement to an A form statement. So we're going to say all S R P. And then step two, we're going to change term complement the predicate. So we're going to say all S are non-P. Okay, the first part, no SRP, is shading in the middle. The second part, all S are non-P, we're going to have to think about for a second. Remember that step one that we have, all SRP, we get rid of that. That's an intermediate step. We're not relying on that at all. It just helped us get to the final answer. So all S are non-P. Let's see. Of all of our S's, S's occur in space 1 and 2. And we want to say of all of those, they are all non-P's. So we want space 1 to stay. Space 2 is a P, and we want that to go away because we're saying all of the S's are non-P's, but space 2 is a P, and this says no, they're all non-P's. So space 2 has to go. And visually then, these two statements match up. So conversion works on the E form as well. All right, let's try the I form statement. I, sum S R P. Step one, sum S, and now we need to say are not. And then step two, this is going to sound really awkward, sum S are not non-P. Now some of you might catch on right away that you have this not non, and it's almost like a double negative in those two things. If you're kind of intuiting that, don't those just cancel each other out? You're right on that, they do. But let's visually walk through how that canceling out works. So the first statement, sum SRP, is, well, you have an S that's also a P, so you're going to put an X in the middle. Then the second statement, some S are not non-P. Okay, so some of the S's, some of the space 1 or 2, so we're dealing with space 1 and 2. Some of them are not space 1. Space 1 is the non-P. Some of them are not non-P, so some of them are not space 1. So of space 1 and 2, some of these are not space 1, so the only space you have left to put it in then is space 2. And so that's some S are not non-P. And you can see visually these match up as well. So obversion works on the I form statement. And the final letter to look at is the O form statement. You have some S are not P. Step one, change the quality. So this is an O form statement. You're going to go over to the I form statement for a quality change. Some S R P. Step two, term complement the predicate. Some S are non-P. Get rid of that intermediary step. Step one goes away. So our starting statement is some S are not P. In step two, some S are non-P. And that one, I think for me, is probably the most intuitive one, that you just replace the word not with the word non. And yeah, it looks the same even the way it's written. But we can knock this out with the Venn diagram as well. So S on the left, P on the right. Some S are not P. It's going to be an X on the left. For the bottom one, some S are non-P, S on the left, P on the right. Some of these S's, which is space 1 and 2, some of them are non-P occurs in space 1, so some of the S's are space 1s. and sure enough, those two pictures match. So obversion works on the O form as well. So obversion works on all four. So to recap for obversion, it takes place in two steps. Step one, you change the quality. Step two, you term complement the predicate. And we know that it works on A, E, I, and O. So there's obversion. Now the final one we have is contraposition. Contraposition is going to be a nightmare to work through, but we'll get through it. Step one, switch the subject and predicate. Step two, term complement both. So practicing with all S or P, you have step one, switch subject and predicate to all P are S. And step two, term complement both to all non-P are non-S. So that's how contraposition works. The problem we're going to have is in visualizing this. If you really get lost on the visualization, just be sure you have the two steps down and you understand how those two steps work, that you switch the subject and predicate and term complement both. But let's focus on this visualization now. So we're going to find out what letters it works on by doing the visualization. All right, let me redraw the Venn diagrams with all the component parts. So you have, for your S and your P, the left side is going to be an S, it's going to be a non-P. The middle is going to be an S, it's also going to be a P, and the right is going to be a P, and it's going to be a non-S. The left side is going to be space 1, the middle is going to be space 2, the right is going to be space 3. And now here the outside matters. You have a non-S and you have a non-P, and this is going to be space 4. Okay, contraposition on the A form statement. All S are P. Step 1, switch subject and predicate. All P are S. Step 2, term complement both. All non-P are non-S. It sounds awful just reading it. All S are P is going to go the way we're used to it going. No surprises here. Shade the left. All S's are P's. Now, for the bottom one, we really got to think through how this works. So S, P. Okay, the first part says all non-P's. Non-P's occur in spaces 1 and 4. 4 is outside of the circles. Space 1 is on the left circle. Both of those are non-P's. And we want to say that all of the non-P's are non-S's. So between space 1 and 4, everything is a space 4, which means space 1 has to go, because we want to say everything is space 4, and so we got to get rid of the space 1 stuff. So space 1 goes, and sure enough that picture matches. So contraposition works on the A form statement. Let's try the E form statement. Okay, no SRP, no SRP. Step 1, switch the subject and predicate. No PRS. Step 2, term complement both. No non-PR non-S. Yikes. Okay, the top Venn diagram, no SRP. That's the way we're familiar with. We're just going to shade in the middle. Okay, let's look at the bottom one. This is the one that's going to, yeah, I don't know what to say about this. It's just crazy. All right. Okay, no non-P or non-S. That's the final statement we're looking at. So the non-P's, where do they occur? They occur in spaces 1 and 4. And we want to say none of these between spaces 1 and 4 are non-S's. So space 4 is where the non-S's occur, and we want to say none of them are, of space 1 and 4, none of them are space 4. So we got to get rid of space 4. We got to get rid of everything outside of the circles. And that looks nowhere near the top Venn diagram. These pictures do not match. So contraposition does not work on the E-form statement. Yowzers. I think the other two are a little bit easier than this one. But yeah, this one, that's just such a weird, seeing the shading go on the outside. It's I don't know what to say about it. It's crazy. Okay, let's do the next one. I-form statement. Sum S R P. Step 1, switch subject and predicate. Sum P R S. Step 2, term complement both. Sum non P R non S. We're going to get rid of that intermediary step. And let's draw the two Venn diagrams. So the top Venn diagram, sum S or P. We should be familiar and confident with this by now. SP, we're going to put an X in the middle. The bottom Venn diagram, SP, sum non-P are non-S. Where do our non-P's occur? They occur in space 1 and space 4. And we want to say some of them are non-S's, and that occurs in space 4. So between space 1 and 4, some of them are space 4's. And so the X goes on the outside. And these two pictures do not match, telling us contraposition does not work on the I-form as well. Alright, let me get rid of this one. And the last one to test is the O-form statement. For the O-form statement, we have sum S R not P. Step 1, switch subject and predicate. Sum P R not S. Step 2, term complement both. Sum non P R not non S. Yikes. Alright, so get rid of the first statement, the intermediary statement. So we have sum S or not P is the starting point, and our final answer is sum non-P are not non-S. Let's do the Venn diagram for the first one. Sum S or not P. You're going to put an X on the left. We should all be confident with that. Now the bottom Venn diagram, S on the left, P on the right. Sum non-P. So our non-P's are going to be spaces 1 and 4. Of spaces 1 and 4, some of them are not non-S's. Between spaces 1 and 4, some of these are not space 4. So the only place left for them to go is space 1. Between spaces 1 and 4, some of them are not space 4, so the only space left for them to go is space 1. And sure enough, those two pictures match. So contraposition works on the O-form statement. So you have contraposition. The two steps are switch the subject and predicate, and then term complement both. And it works on the A and the O-form statements. So 1, switch S and P. Step 2, term complement both. And it works on A and O. Okay, let's go ahead and practice doing the conversion, obversion, and contraposition on a few things. Obvert, all dogs are canines. So you'd have step 1, change the quality. Step 2, you're going to change term complement the predicate. So let's try that with the statement above. Step 1, change the quality to no dogs are canines. Step 2, term complement the predicate to no dogs are non-canines. So that's obversion. Let's try contraposing all cats are felines. Step 1, switch the subject and predicate. Step 2, term complement both. So let's try this with the statement above. You have step 1, switch subject and predicate to all felines are cats. And then step 2, you're going to term complement both to all non-felines are non-cats. Conversion, no cats are canines. Step 1, switch subject and predicate. That's the only step you got. And so you're just going to change it to no canines or cats. All right, now the final question here is what happens to the truth value for the operations? When it's done to a statement that it works on, so when I said that contraposition works on the A and the O, conversion works on the E and the I, and obversion works on all four, in those cases the truth value always stays the same. So if all S or P is true, its obverted form is true as well. If all S or P is false, its contraposed form is false as well. Going back to that first statement, if all S or P is true, so is its obverted form. If it said if all S or P is false, we would also say its obverted form is false as well. So the truth value stays the same. If it starts true, it ends true. If it starts false, it ends false, if it works on that statement. And then finally, if some S or P is false, so is its converted form. So for these three, the operation works on the statement. So truth value stays the same. A true goes to true, or a false goes to false. Okay. Now, when it's done to a statement that does not work on, the truth value is unknown. When you try and convert an A-form statement, so we have, if we remember, conversion works on the E and the I, obversion works on the A, the E, the I, and the O, and contraposition works on the A and the O. So when it's done to a statement it does not work on, the truth value is unknown. So for instance, if we tried to convert the A-form statement, that's when the Venn diagrams didn't match up. When we were trying to convert the A-form statement, they showed two different pictures. And so the truth value of the statement doesn't carry over based on this operation. And so we just don't know what the truth value is. So if no SRP is true, so that is going to be the E-form statement. Its contraposed form, which it doesn't work on the E-form statement, the truth value is unknown. We just don't know what it is. If no SRP is false, its contraposed form is unknown again, because once again, contraposition does not work on the E-form statement. If some SRP is true, so some SRP that's an I-form statement, its contraposed form is unknown, because once again, contraposed doesn't work on the I-form statement. And if all SRP is true, so that's an A-form statement, its converted form is unknown, because conversion does not work on the A-form statement. So if the operation works on the statement will keep its truth value. If the operation does not work on the statement, you don't know what the truth value is going to be. So let's go ahead and practice that. Obvert. All green sloths are mean animals. And let's say that one starts off as a true statement. Step 1, you're going to change the quality to no green sloths are mean animals. And then step 2, you're going to term complement the predicate to no green sloths are non-mean animals. Discard the intermediary step, you don't need it. And then this final answer is going to be true as well. If it started false, the final answer would be false as well. Okay, let's try conversion. No trees are silver objects. Let's say that starts as a true statement. The step one is switch the subject and predicate. No silver objects are trees. And if the first statement is true, the final statement is going to be true as well, because you can convert the E-form statement. All right, let's try contrapose. All kangaroos are good jumpers. Let's call that a true statement. If you do step one, it's going to read as switching the subject and predicate. All good jumpers are kangaroos. And then step two, we're going to term complement the subject and predicate, and so it's going to read all non-good jumpers are non-kangaroos. All non-good jumpers are non-kangaroos. We discard the intermediary step. We don't need it anymore. Contraposition works on the A and the O form, so this works, so the true carries down to true. So the final word for the truth value in the operations is if the operation works, and by operation works we mean A form, the E form, the I form, and the O form for obversion, the A form and the O form for contraposition, and the E form and the I form for conversion. If the operation works, the truth value stays the same. If the operation does not work, obversion works for all of them. So for contraposition, you would say the E form or the I form for contraposition. And the A form and the O form for conversion. The truth value is unknown. Or you could say it becomes unknown. We don't know what the truth value is going to be for the new statement. So that's going to be it for the two things we did today. We went through, once again, the distribution, and then we went through the rules of conversion, obversion, and contraposition. For distribution, when I was doing the sentences saying, okay, we know something about every single member of this group, you can survive this class without knowing how that worked out. So if you're kind of a struggling student and you're having a really hard time with this, both of these concepts I think are pretty tricky. What you need to know is how that chart works. And so if I said for the E-form statement what's distributed, as long as you know the E-form statement distributes the subject and the predicate, the A-form statement distributes the subject, the I-form statement distributes neither, and the O-form statement distributes the predicate, you'll do fine in class. And then for these operations, the Venn diagram pictures I was doing was just to show conceptually why they did what they did, why they were equivalent statements. And so that's kind of more of a theoretical level. I hope you got that. If you didn't get it, you can survive the class. The way you survive is so long as you know that for conversion, it's a one-step process. You switch the subject and predicate, and it works on the E and the I form. For contraposition, it's a two-step process. You switch the subject and predicate and you term complement both. It works for the A and the O form. And you know that for obversion, it's a two-step process. You change the quality and you term complement the predicate, and it works for the A, E, I, and O. And finally, you know that if the operation works, the truth value stays the same. If the operation does not work, the truth value becomes unknown. If you have all that down, you'll be fine. The Venn diagrams, that's not essential to surviving this class. And again, the earlier conceptualization of the distribution is not essential to surviving this class as well. All right, go ahead and get working on your exercises. See you next time. Take care.